Okay, good day, everyone. This presentation actually a little bit to continue the previous presentation bring by Reza, because during this presentation I focus for the equipment that can do power out for other equipment. Then we will monitor the power on the equipment. Okay, so this is the topic. This about me. My name Paul Darius from Padang, West Sumatra, Indonesia. Founder and owner of my own company, SKYnet Solusindo. I know Mikrotik first time about 2004 with RB 220, 230 with wireless card R52. And then this my all certificate, some of them already expired. We renew next time. Okay, this is the screen from Mikrotik certified consultant. I registered one of them. This is my location here. This whole Indonesia, this is the west part. This is my location, this is my working area. As Mentawai Island is really rural area. This the distance, sea distance here, minimum 140 kilometer, maximum of here to here, I think more than 300 kilometer. That's quite hard for radio link or even wireless connection. So this is the bigger picture. This West Sumatra province of Indonesia. This is the Mentawai Islands. There's many small islands here that we have to serve for internet, because many Western resort and surf camp there that accept foreigner for surfing. We can see the next slide. So this is about Mentawai Islands, the biggest regency in West Sumatra. Totally rural area. Here 140, 160 from beach to beach. The distance from Sumatra land. Still traditional. A lot mosquito. Yeah. And earthquake, because so many earthquake happen. Yeah. And best surfing spot area. If you know Indonesia, everybody say Bali is the best, but this second the best in Indonesia. This kind of life in Mentawai still really traditional. Yeah. And this the house traditional there. They call Uma in their language. And this the surfing spot. Yeah. Many Western, Australian, New Zealand going there, even from Brazil, they want to pay to come to here. Okay, objective. When we have the cell tower to serve, customer in rural area, this area have no public power from government. The civilians only depend on generator for genset. We call genset there. No fuel, no power. So for our tower, it's really not possible to use the generator. We have to use solar cell. Here, no commercial power available on the site. Too expensive to run power generator, as always depend on unrenewable power, fuel. Like I said, no power, no internet. So far, only solar panel available as an option. No other option available other than solar panel that can work for 24 hours without interrupted. So most common installation from solar grid go to charge controller, such as MPPT or other. From charge controller connect to batteries and to the loads. The connection to the loads are very vary, depend on the needs. DC cable directly goes to radio, that's the first option. From DC power on the tower feed, go to the radio. Very long. If the tower 40 meter, so if 4 radio, we have to run 4 cable directly from power to the radio. The second option, use the PoE and goes to the radio unit. Quite similar, but there is a PoE at below. The last option, use another unit that controls such as PowerBox or RB750PR2. This example, one of the installation, sorry, that's quite messy here. 3 PoE, so many cable. This only to serve to the radio, but the cable so many here. So it's really sensitive. When you touch one cable, maybe the whole system will down. It's very risky. So this is a problem, not good looking. Too many cables, too many PoE and power adapter. I didn't show you the power adapter here, but we can see this, the power adapter cable. This 1, 2, and 3. This is the PoE, all 3. Okay. And then too many hassle during installation. One touch, maybe the whole system down. It's not easy to do regular maintenance because not everybody know this cable for what radio, this cable for which radio. And the cable may be too sensitive because of the connector, rusty, everything, because we are very close to the sea. To solve this problem, we use this PowerBox or hex specification. You can see this specification on rotorboard.com. 5 port, 1000 Ethernet port, no 1 gig. Ether 1 only for PoE in, and we have 4 PoE out at 2 to 5. Per port maximum 1 ampere. So if we put 24 volts, 1 ampere means 24 watts for each port. But this unit limited maximum 2.2 ampere for the whole system. It supported input voltage from 8 to 30. The input here and the output here should be same voltage. So if we put 30 here, 30 out, 12 in, 12 out. So there are no power voltage regulator here. Voltage monitor, yes. So we will focus for voltage monitor. Maximum power consumption for this unit only, outside of the power out. So the unit only will consume maximum 3 watts. So if we can calculate 1, 2, 3, 4, all, let's say all of them 10 watts, add another 3, so total 13 watt. That's for the example. The product variant for this is the product variant. So this is the first release, RB750 UP, shown on the previous picture. This is the unit, how this looks like. And this the next product that can do the same function. RB750 UP R2 or HPUE Lite. There is U here, means for USB. If you need USB, choose this 1 and 2, but this no more on production. This one is called PowerBox, no USB port. This also have a PoE. I never use this, but I found it on the rotorboard.com, the product list. And this also Omnitic. There are many kind of Omnitic, But if you need the power out, choose this kind of product. For detail, see routerbot.com if you need more detail, the specification about this product. So this is the example that we did in our city, one of the installation. One unit RB750 UP, 5 cable here, 1 in, 4 out. This should be green. These are red. If it green means no power out. The red is a power out working. So these all 4 port on and power all the equipment connected here. Yeah. The installation with the PowerBox or HPOE look nice, pretty, because so simple. Here, 1 cable for each device. Only 1 power adapter need, so not like a previous picture. 3 radio, 3 power adapter. Here we only use 1 power adapter for all equipment. No PoE unit needs, no hassle on installation, easy to do maintenance. So if we know which radio we spot, just unplug the cable, do maintenance, and plug the cable again. Turn on, off, or reboot can be done remotely, not like the previous picture. If you want to switch off the equipment, unplug the cable. But with this, we can do remotely by command or by GUI. And the last, the add-on, the monitoring. We will focus on this. Yeah. Next, this is the direct monitoring. If you want to see the current condition, let's say we open the Winbox now, go to the console. If we want to see the current condition, do this command. Interface, Ethernet, PoE, monitor fine. So we can see all 4 devices connected here. 1, 2, 3, 4, all the same voltage, but different current and different watt. If you want to know the total, just calculate all 4, and that's the total watt output consumed by all the radio. Yeah. But with this condition, we doesn't know how the condition last night, or an hour before, or 2 hours before. So we want to see the power on history. Okay. The info show on 1 unit power with 4 devices connected and power. What we talked about, say before. As the input voltage may be up and down, we cannot gather the historic info. That's the difficulty of this picture. Because we use solar panel, during daytime the voltage is high. During nighttime, the voltage should be low because we depend on battery. But during daytime, there is a sunlight and charge. So daytime we doing charge, nighttime discharge. So you want to see the power history here. This one of, with the proper setup of SNMP, both on rotorbot and the DUT, so we use DUT for this monitoring, we can get monitoring feature like this. Yeah. So this from 00 until this last 24 hours. So we see here, this discharge lower, and when the sunrise, the voltage up from the solar panel, and then the weather condition perhaps not good enough, the voltage drop a little bit, but till the afternoon, no more sunlight, and the voltage drop. But still above 24 volts, they should be okay. What we can see here from this picture, when the power high, the currents become lower. When the voltage lower, the current up, but the power consumption slightly stable here. Here is quite fluctuated depending on the power input, the voltage up and down. This is the situation. Okay. This picture for 24 hours monitoring. Next, this for 12 hours because we doesn't care about the 6 hours before, 6 hours after. We focus on during daytime. This for 12 hours. You can see here the voltage history. So if we go to Winbox and see the voltage, this hour, this is the voltage we can see. During this hour, we come higher. This hour, about 27.4. This lower. So we cannot get this kind of history if we not use DUT with the SNMP. This is the current fluctuation according to this. This is the what? The power consumption. On the previous picture, 1 unit PowerBox power with solar panel on rural area. The mentioned PowerBox connected to 2 devices and power up. Here, PoE on HZ2 and HZ3. So it's only show 2 devices here. On the previous picture, here 4 devices. There's that I show you the example, and this only 2 devices, and this also 2 devices. If we connect another devices like devices 3 and 4, we can put this so we can see 4 different graphics here. Yeah, the picture show the input voltage during last 24 hours, the last 2. To change the change of the input voltage will impact to the current supply into each devices. This is what I mentioned. So this up, this is go, because it's maintained for the watt. So it's not the error. This is really like this because for the same current, it means watt. If the voltage up, the current should be down. Yeah. This another 12 hours daytime use. So from this picture we can see there was weather changes during daytime. There's a good weather and then bad weather and good weather again until the afternoon and discharge. Even if we are far away from the equipment, we can probably know what happened about the weather, not to see, but probably we know. Because the power up and on, it's probably quite bad weather or cloudy around these hours. If you use static power, like power adapter, normal adapter, this the picture looks like. Always stable. The current, the power, all stable. I don't think there is anything we can do here because the power always stable. Nothing to do monitoring. Unless the power cut off, we can see off and up, but not the picture like this that the power up and down. Okay. No monitoring needs of the stable static power. Conclusion. With the proper setup of SNMP, SNMP is simple network monitoring protocol at router boards and the DUT, we can monitor not only the device's status and bandwidth, but the power parameter as well. The devices will consume almost the same amount of power, watt, at any voltage supply. Like we see here, this almost the same during 12 hours, even if the input keep changing. The higher of input voltage will trigger the lower current supply, but the lower of input voltage will trigger the higher current supply. Next, with the power situation graph, we will know the battery bank capacity compared to the output power supply. We will know when the battery bank needs to be replaced and or added. So here, we see still above a 13.4 means the power is still okay. We install 2 times 24 volts, 100 ampere here. We put in series, so should be 24. If the voltage during night time, we focus on night here. If during night time lower than 24, means the battery need to maintain or replace. Because will trigger a higher current, will make sometimes the rotor board off if the power too low. The graph also show the weather condition during this time. This is as a bonus, like a previous picture. This we show the current condition. For advanced usage, we can put script that will send an alert by email and or SMS when the voltage lower than the certain value. We define which value the lowest one. If lower than that, the system will send SMS, email, or whatever you want, or maybe pop up on the dirt. On this picture, let's say for 24 volts, if lower than 24, it will trigger the notification. Any question so far? Because we didn't have a demo, we shall now need to show what we did on the field. Any question? No? Okay, thank you for watching. For any further question, inquiry, you can email me on this. Thank you.